want to introduce you to my cousin. This is Gary. Gary has a few brothers. It's Gary, Larry, Terry, and Hal. And I only tell you that because it makes me laugh. So Gary is my cousin, and one time we were at a family reunion, and he pulled me over and he said, hey, he doesn't call me Mrs. Pryor, but he said, hey, Holly, do your students know the secret? And I looked at him a little strange and I said, I don't know, Gary, what's the secret? Now, something you need to know about Gary, he's a carpenter and he builds a lot of things, you know, cabinets and bookcases and things like that. And like all carpenters, he likes to get right angles in things. And so he said, well, let me tell you. And he took a napkin and he drew a picture of a bookcase. Obviously, it wasn't this nice of a picture. It was on a napkin anyway. But he goes, this is the secret. And he said, a lot of times I have to know if I have a right angle when I'm building a bookcase or something. And I am way too lazy to go out and get my carpenter square to check that right angle. So I just pull off my tape measure and I just measure out. And I measure out on the side. And he said, he actually drew this. He goes, I measure out on the side and I see 3 inches. And I just put a mark 3 inches in. And then I mark up the other side 4 inches. And then I just check with my tape measure and I just see if this distance between the marks here is 5 inches. And if it is, I know I have a right angle. And he actually marked it. He was all geometric about it. So he says, I know this is a right angle if those measures work. And I said, oh, he goes, it's so awesome. I hate going out to the truck all the time to get my tools. And I said, well, Gary, actually they do know that theorem, or that secret. I didn't call it a theorem. But he was pretty proud of himself. So I hope you guys know that. We saw that in the last lesson, 3 squared and 4 squared, that 3, 4, 5 right triangle. But really what he was doing is something called the converse of the Pythagorean theorem. And it says this, in a triangle with sides A, B, and C, that was his 3, 4, and 5, if C squared equals A squared plus B squared, then you do have a right triangle. And so this is the converse, remember? So we're actually switching around the Pythagorean theorem. Last time we started with a right triangle and we knew the formula would work. This time we're going to say that if the formula works, if C squared in our triangle is equal to A squared plus B squared in our triangle, then our conclusion would be then we have a right triangle. So I would know from that equation that there was a right angle in it. Now let me show you with an example. The question is now, is this a right triangle? And all you know is the 3 sides of it. So we're going to test this. So first of all, if it is a right triangle, which side would be the hypotenuse? So that's going to be the longest side each time. So this is the C that I want to test here. So I'm going to take 14 squared. I'm going to square that, and I'm going to compare what I get when I do that to 7 squared and 12 squared combined. Okay, so calculating this, 14 squared, that's actually on your number line. You ought to know that. That's 196, should be memorized. These guys are 49 and 40 and 144. And when they get added together and combined, that makes a 193 total. Is that right? Am I adding that right? Yeah, I think I am. 193. Okay, so 196 and 193. Here's the question. You'll notice I didn't put any kind of equal sign because I didn't know if they were equal till now. Now I know they're not equal. So 193 and 196 are not equal. Therefore, is this a right triangle? It can't be. This is not a right triangle. No way. A squared plus B squared has to add up to equal exactly C squared. How about here? Is this a right triangle? Let's check it out. If it is, this is my C value, the biggest one. So I'm going to do like I did before. I'm going to take 34, got to square it. I want to compare that. I'm going to put a question mark. I don't know if they're equal. I'm going to compare it though to 16 squared plus 30 squared total. Okay, let's calculate it. Punching it in, 34 squared is 1156. And now let's check out the other side, 16 squared. You guys have that one memorized? That's not one that I told you to go up to, but you ought to anyway. 256. And I actually know 30 squared is 900. So when I combine 256 and 900, I get 1156. So are these the same? Well, absolutely. So since they're equal, because they're equal, I know this is a right angle. I can put it in there and I can say yes. That's our test. So that's the converse. It's pretty straightforward, but we do get some extra information from it. We know that if c squared is equal to a and b squared combined, and that of course would be my missing side here for c, then I have a right triangle. That's obvious from our theorem. But what would happen if I were to change the angle? And that's what these other pictures are about. In this first picture, we have changed the angle, so it's not a right angle anymore. Now I've opened it up a little bit wider and I've made it obtuse. So this one's obtuse. What happened when that angle opens up more? What happens to the length of that side C that was across from it before? That got bigger. So we would know this. If you look at your C value in your C squared in your Pythagorean theorem, and it is bigger than the a squared and the b squared. So let's put a greater than in there. If c squared is bigger than a squared plus b squared, then the conclusion that we can make is that we don't have a right triangle, we have an obtuse triangle, because that angle had to have gotten bigger. Okay, now by the same thinking, if we were to take that angle here, that right angle, and close it in, just close it up a little bit, then now it's going to be an acute angle. So we're going to have an acute triangle here. Well, what happened to the C length that was across from it? If you compare that to what we had when it was a right triangle, that got shorter. So our last part of this theorem is that if the C squared value is smaller or less than the A and the B squared values, then we have an acute triangle. So we actually can tell what kind of triangle it is just from knowing the numbers on its side. That's pretty awesome and helpful. So let's look at some examples. Now these don't have the pictures drawn, you just get the three sides, but we're going to classify as acute, obtuse, or right. So our first thing is to decide which one we're going to use as C, and that's always the biggest one in the list. So that's, in this case, it's 18. We're going to take that C and square it. And then in a separate calculation, we're going to take the other two sides and square them and add the total together. We want to know what the relationship is, equal, greater, or less than. So let's check out 18 squared. All right, 18 squared is 324, and 7 squared is 49, 13 squared is 169. So when these are joined together, let's add that up, 169 plus 49, that's 218. Okay, so now we can make our comparison. Let's say 324, our C squared value, that's bigger than our A and B squared combined. So what kind of a triangle does that give me? Looking back over here, it was bigger, that means it's obtuse. So this is an obtuse triangle. All right, and we don't even have to see the triangle to tell. Now with this next one in number 2 here, you might look at that and think scary because of that square root, but it still works the same way. So we're going to just have to figure out, our first step is which one of these is C. Now it's a little tricky because the square root of 6 is some decimal, it goes forever and ever and ever, on and on. But is it the biggest of the list? Well, if you're not sure, take the square root of 6 and make a note of what that decimal is. So that's about 2.4. About 2.4. Now I don't want to use the 2.4. I have to use the exact value for the test. But it does tell me that 4 is the biggest one. So 4 is my C. Of course I'm going to square it. The others are square root of 6. I'm going to square it, remember. And then I'm going to add the 3 also squared. So 16 for the C squared. When I square and square root this number, do you remember what happens? Hi-ya! Cancels that square root, just gives me the 6. And then I take 3 squared for 9. So combining these is 15. How does 16 compare to 15? 16 is bigger than 15. So again, we have an obtuse triangle. Next one. Which is the biggest side? That's my 25. So I'm going to take 25 by itself and 7 and 24 together, squaring them out to check. This is going to be squared out to 625. Who's impressed that I know that? This is 49 and 24, let me think. I think 24 is 576, but I'm going to check me. I don't trust my memory here. 24 squared is, oh, I'm right, cool, 576. All right, when those are added together, you get 625. And what do you know? This time they're equal. So this is back to our Pythagorean theorem. This is just a right triangle. Okay, be honest with me. Who saw that at the beginning? Because this is a triple from our last lesson, 7, 24, 25. I told you if you memorize them, you get to save a bunch of work. You can see it. How about here? All right, this is the same thing again. Just find the biggest side. That's your C. Pull it out, square it, and then join these other ones with their squares and make your comparisons. That's 100. This is 25 plus 64. Those are adding up to 89. 100 is bigger than 89. I can't believe I got another obtuse one. I'm going to have to find some better examples. Please don't think that the answer is always obtuse. You can get acute ones. Okay, I'm hoping for this next one to be acute. Let's see. Decimals, no problem. We can handle them. Which one's your biggest side? Let that be C. Pull it over by itself and let the other two get squared and added. I'm glad I have a calculator here. Okay, 2 squared is 4. Never mind, I don't need a calculator. 1.2 squared, that's kind of like 12 squared with a decimal. That's going to be 1.44. 1.4 squared is 1.96. Check me if you don't believe it. You better check me. Combine those together. What do we get? Oh, see, now it's sad. I can't add them. 1.44, don't tell your parents. Plus 1.96. They'll be so disappointed in me. 3.4. Oh, what do you know? Again, another obtuse one. 4 is bigger than 3.4. Obtuse. Do the try these. I'm hoping you'll find an acute angle. You tell me.